Again, we are looking for absolute maxes and mins. So we learned that your only possibilities can occur at critical numbers or endpoints. So I'm going to start by finding my critical numbers, which is where my derivative is equal to 0 or does not exist. So this factors nicely, so my only critical numbers are plus or minus 2. So I'm going to take these numbers as well as my endpoints and plug them back into the original function. And you can use your calculator to do this arithmetic. So I'm going to take f of negative 3, f of negative 2, f of 2, and f of 5. If I plug it back into the original function, my y values are 9, 16, negative 16, and 65. Since these are your only possibilities where maxes and mins can occur, the highest y value has to be the highest point on the graph. So 65 is the highest y value, so that's my max. And then negative 16 is the lowest y value, so that's going to be my minimum. Okay, let's try one more, the next one. So again, start by taking your derivative. I'm going to bring down the 2/3, reduce the power by 1. The derivative of 2 by itself is just 0. And I'm going to clean this up a little bit before I might find my critical numbers. So there's no place where this is 0 because the top can't be 0, but there is a place where the derivative does not exist. If I plug in x equals 1, you get 0 on the bottom of the derivative, so that value does not exist. And x equals 1 is a point on the graph, so it is a point on the domain of the original function, so that's fine. So I'm going to take my endpoints and my critical numbers and plug it back into the original. So these are your only 3 possibilities for maxes or mins, absolute on the original. If I plug this into the original, you get a y value of 2. This is going to give me 3. This is going to give me 6. So this is the smallest y value, so we would say this is the minimum. This is the biggest y value, so we would say this is the maximum.